name of the chapter is polynomials, and it is a type of algebraic expressions. But let us just recall what are algebraic expressions. First, let us see what are variables. So the word variable means something that can vary or something that keeps changing. In mathematics, a variable takes different numerical values and its values are not fixed. It is denoted by small letters and the examples are given here. So as you know, variables are just small letters, but if there is a combination of constants and variables, we call it algebraic expressions. And so algebraic expression is a combination of variables and constants. So these are few examples of algebraic expression, because you can see here you have combination of a 4 and x, 4 being a constant and x being a variable. Here also you can see that there are constants. There is -1/2 as coefficient here, there is 7 here, there is also 1 as coefficient with x here. So there is 1 as a coefficient with x, so constant and variable. There is -1/2 as constant here, and there is x again, so you have combination of constants and variables. And in the last example also there is a combination of constants and variables, and so all of them are algebraic expression. Constants means positive, negative, fractions, all numbers are constants basically. All numbers are constants. Now if you look at this algebraic expression 4x, it has only one term, which is 4x. This expression has only one term, and the factors of this term are 4 and x, and we know that the factors are multiplied to form the term. So 4 into x becomes 4x, and from this 4 is the coefficient. Moving forward, if you take the second example, you can see the terms are x squared, then -1/2x is the second term, and the third term is 7. And terms are always added to form the expressions. So though there is a minus sign, we know that it's actually added to form the expression. So it's like this, and plus into minus eventually became minus. But terms are added to form the expression, and each term has factors. So now let's look at their factors. The factors of this term are x into x, and we know the coefficient here is 1, so I'm just going to place 1 here. The factors of this term are -1/2 into x, and the factors of this term is just 7. So if you can see, the coefficient is 1, here the coefficient is -1/2, and here the coefficient is 7. Remember, we know that with 7 there is a variable x, but it is of a power 0, which we don't write because anything raised to 0 becomes 1. So we don't mention it. Now let us spot the difference here. Since the variable is in denominator here, we know that if we had to bring it to the numerator, the power of this variable is going to be -1. However, here the power of this x is going to remain +1. In this case also, you can see it is x raised to -2 plus 5, because x square is in denominator, so the power becomes negative if we take it up in the numerator. So this could be written like this. However, here there won't be any change because it's already in the numerator, so this becomes x squared plus 5. And so the difference between this left side and the right hand side is the powers here on the left hand side are negative, but the powers here are positive. Powers are also called exponents. So we have spotted the difference that exponents here are negative numbers, but exponent here are whole numbers. Why are they saying whole numbers? Because x5 also has a power of 5, also has a variable x which has a power of 0 here. Here also 5 has a variable x with a power of 0. So here you can see this is negative numbers including 0, and here it is positive numbers including 0. So this this set becomes whole numbers because all the positive numbers including 0 becomes whole number. So, and this set of expressions are called polynomials. So what is the definition of polynomials? Polynomials are algebraic expressions where exponents are whole numbers. So you must remember that the powers of the expressions are always going to be positive numbers or 0. So polynomials are algebraic expressions having whole numbers as exponents. Okay? State whether the following expressions are polynomials or not. Now let us look at the first expression. Here x is in the denominator, so if I had to place it in the numerator, it will become x plus x raised to minus 1. This will x has a positive 1, but the second x has a negative 1, and therefore it's not a polynomial because the exponent is negative. If you look at this, it's square root of x, and here x has a, if you take x, remove the square root, then in power form, you can write it as x raised to 1 upon 2, and it's a fraction. Fractions are not whole numbers. And though here 3 has a power of 0, because one of the term is a fraction, has fraction as whole number, as exponent, since the exponent is a fraction, this term is also not a polynomial. Here y has cube root, and so if you remove the cube root, sorry, this has to be y, it would be 1 upon 3, and again as the exponent is a fraction, this is not a polynomial. But if you look at this example, here x has a positive 3, and what do you think what is y's power here? It's positive 1. And since both of them are whole numbers, this one is an expression. This expression is a polynomial. Now remember, we don't look at 1 upon 4. 1 upon 4 is a coefficient. Fractions are allowed in coefficients. They are not allowed in exponents, so they cannot be powers. Here, both the powers are positive whole numbers, and therefore this expression is a polynomial. Here you can see it is positive 20, and again y is 1. So again, both of them are exponents, and so exponents are whole numbers, and so this expression is also a polynomial. Again, root 4 here is a coefficient, not the power of y, and therefore it's okay to have root 4 in the coefficient. Okay. Give the number of variables in each of the following polynomials. How many variables are there? There is only one variable, which is x. All of them have x. Here also we can say that there is x variable with a power of 0, and therefore this polynomial is called polynomial in one variable. Look at this one. It has y square and only one variable y. So this is also a polynomial in one variable y. However, the third one has two variables t and y. Y also has a power of 1. Both of them are polynomials. All three of them are polynomials because the powers are all whole numbers. So, but because it has two variables, we will call it polynomials in two variables, t and y.